All right, everybody, good morning. Welcome to the webinar. My name is Brian Metzger. I'm a 3D scanning solution specialist here at TriMech Solutions. And we are going to be taking a look at what to us is a new tool that's going to help us manipulate our 3D scan data or even 3D geometry that we start from scratch in a very free and organic way, almost like clay sculpting. We're really excited to get started with Geomagic Freeform. I want to introduce to you Dave DiPinto. Dave has been a member of the Geomagic Freeform development team since 2009. During this time, he's worked as a test engineer, an application specialist, and in product management as a product owner. He's got a background in 3D art and software engineering, and he's going to enjoy the opportunity to use all of his skills to improve Geomagic Freeform. I'm really excited to see what he's got to show. Quick little logistical note, Dave is going to be sharing both what's on his screen and a webcam so that you can see the haptic device. I'm going to encourage all of you, once the screen splits and you have two things being shared, the webinar will have a split screens button at the top that will put those into two separate windows. So if you're like me and you've got a two monitor setup, go ahead and hit that button and you'll be able to make each one full screen on a different monitor. With that, I'll mute myself and Dave's going to take it away.
Thank you very much. I hope you can all see my screen right now, and allow me one moment to turn on the webcam. It looks like everything's functioning, so welcome. As Brian noted, that this here is Geomagic Freeform. This is a product that is used in a variety of industries, and it is a absolute wonderful tool to use, both for its power and the pleasure of actually feeling like you're touching and sculpting and working with a digital medium in a way that no other tool offers. So the haptic device that I have in my hand right here, this actually provides 6 degrees of freedom to move around the screen. If I bring up a file, so the first thing that we are going to look at, this here is a scan of a hand, and we're going to make a very simple wrist brace for it. But you can see as I move my stylus around, I can move in space. I can actually touch and feel the surface of this model. So not only do I get pointing ability, do I get the ability to rotate and move, but there are motors inside this device that actually engage and give me a tactile feedback, which is unlike anything else, and it provides an experience and a usability that you do not get elsewhere. So this model, I'm going to begin by duplicating. Actually, I'm not going to bother with that. I will start by selecting an area. So what we want to do is we want to make a brace that covers part of the hand and part of the forearm. So if I paint a selection on this model, I can do this by simply touching it and painting with this stylus. I can use slightly more precise tools such as the ability to draw a box or a polygon to select. And from here, if I bring up my side view, you can see that I can select in depth. As I move my hand forward, I can choose what I'm selecting. When I click, you will see that area of the model turn green. And I'm actually going to straighten out the back side of this brace so we have a nice clean line. And from here, I am going to emboss this, which is going to raise this off the surface and give me a perfect offset of the geometry. So I'll do this at 3 millimeters, raising it off the surface, and we'll give this a preview. I also use this haptic device as my pointing and view tool. So while holding the G key, I can move around and I can look at my model in a much more organic and user-friendly way. And we can see that I missed a part of my selection. So I will turn off my preview and I will paint that in, as well as remove a little bit of paint from the thumb. That would probably be uncomfortable. So I turn this preview back on, and that looks great. So I click apply, let the calculation complete, and now we have an offset from that hand. To make this a separate piece, I can use the original scan, which was a mesh that came in from a scanner, and I can Boolean remove. And the piece that I was working on that has the offset is called arm clay. Remove that. Let the calculation finish. And we can see that now this here is a brace that follows around the shape of the hand. And if I turn back off the arm and look inside, you can see that it actually captures all of the detail of the palm. It is a perfect replica. So we do have a little bit of cleanup work to do. And this does show another beautiful aspect of the haptic device. So I can choose where I want to smooth. And because this is a clay representation, these are voxels. So this here is more than just a 3D surface. I can use my haptic device, go inside that surface and pull against the surface. So I can feel that ridge and make a selection based on what I feel. So I'm not limited to what I'm looking at. I don't have to worry entirely about view either, because I can feel the groove of that ridge. And now that I've made that selection, I can click smooth, and as always during demonstrations, my laptop is deciding to run a little bit slow, but that's okay.
Dave, I hate to interrupt.
Yes.
I'll real quick note, somebody in the chat was saying they're having trouble seeing the webcam. I know if you're in full screen mode, you won't get that button that splits the screens. There's also kind of a horizontal bar that you should be able to drag up and down. Sometimes that gets put all the way to the top or bottom that would block one of them off. So Daniel, if you still can't see it, put another note into the question box.
Perfect. I hope that does help. And once you have the screen with the haptic device up, you do notice that for every movement I make, the stylus does move around on screen. And actually, a proof of what this is doing. So I'm going to momentarily damage this brace, just because this is a great example of the haptic device and what it does. So I'm going to take my carving ball and make it a little bit larger. And right here on the top of this surface, proof, because right now you can see as I touch, my hand is actually vibrating with some spring force. I can carve a little bit of a groove into the top of that surface and rest the stylus so it sits there and the motors hold it in place. So there is true tactile and visible feedback of what's going on. And it does provide a very unique experience. So now that we have part of this brace, I want to very quickly split this in half. So there are many tools that you can use to split this. I'm going to start by pressing my D key so I can see through my model. And I am going to select and follow a reasonable path. Select in space. And now I can cut and paste as a brand new piece. And we have the two halves of this model. So I want to work with the top part. And I'll turn back off see-through. Actually, you can see the inside. Actually, I will work with the bottom. So one of the things that is also unique about Freeform and how easy it is to interact, I can draw 3D curves directly on this surface, fit to the surface. So for instance, in this palm region, if I wanted to add texture, something to add a little bit of grip, a little bit of something to differentiate the model, I can define a region. I'm just clicking and touching the surface. And I did turn on automatically fit to the clay, which means I only clicked several different places and that region is now fully defined. Those curves stick to that surface. And I can use my emboss tool, select this, pick inside, and I want to use a pattern. We don't want 5 millimeters. We want about 0.5 millimeter, maybe a little more. So want to raise this off the surface, and I can do this interactively. I can use my on-screen tools to move this texture around. I can rotate it, I can scale it, and define how deep in or out this is created. And when I'm happy with it, I click apply. And because the resolution was low on the preview, I will repeat that and do a slightly, oh, so yeah, the distance is very high for this. So lower this down to right around here, and my preview now will match better when I click apply. There we go. So now the palm has some texture to allow a little bit of grip, and I will also go around to the top side, hide those curves, and I'm going to make some perforations in this, but I will begin by doing a selection around the edge of this model, because what I want to do is I want to protect part of this model from being removed. So if I make a selection that covers the outside edge as well as up here, actually I'll go around the thumb as well. What I can do is I can mask this. So this here is just like when you're painting, you would apply masking tape to a region you don't want to get paint on. So we do the same thing in 3D. I'm going to wrap an image around this. So I will use the wraparound cylinder. And I want to change this to more closely fit my model. So I have to, of course, align the projection. So I'm going to look from this view, that right about there. And now switch my texture. change the size back. And I'll set the distance to something that is larger than the thickness of this piece. So I'll set it to about 5 millimeters going inwards, and we'll look at the result. We don't see the holes in it because it's actually just pushing the surface down. So when I click apply, we will see that the clay colored region is affected, but nothing that I had chosen for my mask. And because I have the original scan data, which I can once again remove from the piece, everything that would have been inside the hand is now removed. The red region is still protected. I can select all of this and even smooth it a little bit. And when I'm happy, go back into my select tool, remove the mask, and we have an arm brace that is in 2 separate pieces, texture on the palm, and it will perfectly fit this customer. So this is one of countless workflows that can be done with Freeform. As you can see, we work with we work very well with organic data. And the next demonstration that I'm going to do involves a scan that was done of a trophy topper. So this model here is a top of a trophy from a sport called hurling, which has 2 players, large sticks, the ball, and I'm going to import this as mesh because I want the original data. I don't want to have it converted to digital clay. And this was done on a scanner combined, and as we can see, there are holes in the data because it was a line of sight scanner and done on a turntable. For instance, parts of the face are missing, part of the chest, there are holes underneath the arms, parts of the sticks. Clearly, there is some work to be done. The first thing that we notice too, you can see the triad right here is the world coordinates. I typically work in Y up, and this model here comes in the space that it was scanned. So what we want to do is make sure that this here is aligned for our world so we can work more easily. We have fantastic tools for fitting planes and curves and points, so I can make a selection here on the bottom of this part, click apply to create a plane, and switch over to my align to origin tool. Now simply select that plane, and I can interactively choose which orientation I want this. So I want this in Y up. I'll align my view to the world forward, and I can see that we're upside down, so I'll flip it. Click apply and hide that plane. Now, when I look from my normal views, I can see that the workpiece is in a great orientation. And I can begin systematically refining parts of this model. So, as I mentioned, that this here is a mesh representation, which is why it's purple. This is just polygon data, and we need to convert this into digital clay in order to work with, in order to use our sculpting tools. I'm going to start with the face of this gentleman right here. So I go to my mesh selection, and I'm going to make a very loose selection. Just something like this. Because I want to copy this as a brand new piece so I can work with it independent of everything else instead of taking it apart and working with the entire volume at once. This way here, I don't have to worry about the line of sight. I don't have to worry about interacting with other pieces, and also it'll improve performance. But I need to remove some of the extra data that I don't need. So from this view, since I am mostly going to work on the head, I can select this, invert my selection, and delete. And I don't need part of the shoulder and the arm, so come over here, trim off that. And now I will convert this to digital clay. Very easily done, copy to clay, and I can choose the resolution. Voxels work in a real world scale, so what I'm going to do is choose a 1/4 millimeter. So that means that this will be sampled on a cubic scale where every 1/4 of a millimeter we're going to determine whether it's volume or not and add the material appropriately. I need to fill the holes. I want these curved because I'm going to be sculpting and cleaning a lot of this up, but I need a solid watertight model to begin with. That is the other big advantage to working with digital clay. This, if it renders as digital clay, we are nearly guaranteed that this is solid and watertight because it has to be a volume in order for us to see it. So now that I have this part of my model, I'm going to create a plane, put it here in the center, because I want to mirror this piece. So line it flat to view, rotate it, and I'm going to try and see if this will work for automatic symmetry to see if, actually I need to make a selection down the center in the area where it's most symmetric. And let's see if we can define a symmetry plane. So I select the plane that I have that's closely aligned, click apply, and let the calculation run. Nope, I did not select enough, or there's too much data that is non-symmetric. That is perfectly fine. I can eyeball this. So under construct clay, choose mirror. I'm going to rename this mirror head. So I can pick that from my list. And when I choose preview, it's mirroring across the wrong side. Flip it. Might be a tiny bit narrow. So I can interactively adjust my mirror. Now the nose doesn't look right. That looks a little too big. That will do. Click apply. And now with this mirror applied, I can interactively carve and sculpt on this piece. So turning on my interactive mirror, for instance, if I want to smooth around the eyes, I can do that. And you see it update on both sides. I can use my deformation tools like tug. And if I want to fix the earlobes because they look like they're sticking out a little bit, I can push those in. And the larger view of what this tool is doing, if I make my tool very big, I can click on part of the head and I can actually grab and pull this around. And when I let go, it's going to resample and calculate that volume so it fills itself in and it does not distort the surface. So the advantage here is you can make large deformations, large changes, and not have to worry about topology, not have to worry about edges and faces and stretching because the volume calculation is going to take care of all of that for you. So from here, if I want to, I can basically carve and fix this face. So the mouth is a tiny bit pinched. So I can use my fill to fill in around the cheeks. I can tighten up the lower lip. Extend that out. And because we're happy, I can make him smile. Click the side and I can pull up the sides of the cheeks. So he's now very happy. And if I turn on not the head, but the rest of the model, you can see that everything was done in place, and I can continue pulling parts of the model apart. I can trim off parts and convert more and systematically go through and clean up scan data that would have been virtually impossible or entirely impossible using traditional CAD tools. So for the challenging cases where you cannot work from sketches or lofts and extrudes and the bread and butter of prismatic CAD design, Freeform gives you an entire tool set that is unique and provides a manufacturable and deliverable result. So that is another thing that separates this from content creation tools. Most content creation tools are meant for 2D or meant for graphic design or film, video games, things like that. Freeform, from the ground up, is designed to deliver a model that is going to be prepared and ready for either 3D printing or any other type of downstream manufacturing. We've hit about half an hour, so at this point, if we'd like to take some questions or if there's anything in particular people would like to see, I'm happy to work off of suggestion as well.
Awesome stuff. So guys, if anybody joined partway through and didn't hear the explanation at the top, there is a question box in GoToWebinar. You will not be able to use your microphone, but please type questions you have into the chat. And while everybody is getting those first ones in, I want to ask the question, Dave. I've worked with customers who do kind of digital sculpting, visual media, and in other programs, and talked about the difficulty of keeping the surfaces, for lack of a better term, well behaved. The kind of thing that can happen is surfaces can self-intersect, they can get twisted up, you can get something other than a single watertight body, which you need to have in order to 3D print. How's that different in Freeform?
So in Freeform, when you're working with voxels, the calculation is always done off of volumetric data. So, for instance, if I look at this mesh, I can turn on my view for wireframe. And of course, this is a dense mesh. You can see this is made up of a variety of faces, and these will distort, these will stretch and pull no matter what you do to them because they just exist as points, edges, and faces. Now, with digital clay, for instance, if I turn that back off and come back over to the head, in order for this to render on screen, we have to have a view that shows the faces. So if I go to wireframe, you can see that there is a wireframe, so it previews, and this is also what's used when we convert back to mesh for reduction and exporting. But if I make an adjustment, I can pull and tug. As soon as I release, the calculations happen again, so the surface is going to be adjusted based off of the data that is inside the volume. So
in other words, no matter what you do, as you're making changes, you're always working with a single watertight body, something that could be exported to something like a 3D printer.
yes, you would have to basically you would have to try very hard in order to make something that is not going to work downstream. I mean, I could theoretically, if I try to flatten this to the point or pull it through itself, you will see that we do get some anomalies in the surface, but they're obvious and visible. Actually, let me change the clay back to smooth. But under normal working circumstances, you really have to try hard in order to make the clay not behave properly. And I'm going to open up the final result of this. So after a little bit of effort and work, the statue itself, there we go. Oh, the file, there it is. So if I turn off my paint, we can see that this model here, I will switch over to the clay version. So the ball and sticks were repaired, the hands were given greater detail, the jersey and the face were resculpted, as well as definition in the legs, the shoes, texture on the surface. All of this done within Freeform and done much more quickly than you could do in so many other tools. And this was turned around and 3D printed. So this, I know for a fact that this model here was given out and shared at a local event some years back.
Very cool. And that kind of addresses another question we had from I'm not sure if it's Guy or Guy, was asking how you would rebuild the paddle that has been poorly scanned.
Oh yes, so the paddle, that there are so many different ways to do that. You could create it based off of reference sketches from looking at it. You could copy the paddle that is intact. So if I hide the clay and go back to this statue, we can see that one of them is broken while the other is not. So really, if I were to do this very quickly, I could select this. Oh my goodness, Freeform blew up. The curse of live demonstration. I'm more inclined to blame my aging laptop than I am the software, but this is a great reminder to every single designer out there. Save frequently and save multiple versions.
Absolutely. Other questions we're getting so far is, would it be possible to add some features parametrically? The example given is adding in a screw boss in a pattern.
So Freeform does not have parametric tools itself, so we cannot create something that has a history tree, though we do have the ability to import CAD data, so we can bring in IGES, STEP, SolidWorks part files, and combine those. We can work with solid NURBs and mesh representations. So if you have something that's designed elsewhere, you can incorporate it. But we do have a simplified sketching engine. So if you have a 2D plane, we have a sketch suite of tools, basic tools, so like line drawing, freehand sketching. So I could create, for instance, a box. I could put a hexagon inside of it. I can select these and loft these as a solid. So if I select both of those and set my distance to 20 millimeters, we get a preview of the resulting box. I click apply, and we have a solid. But unfortunately, now there's no way to go back and edit the sketch and have this automatically come forward like you would in a traditional parametric CAD program. This is more of a linear workflow where you do your creation and then it's akin to working with your hands in reality, where you would create something and then it exists. So we have the ability to undo, which you don't in the real world, which I am absolutely thankful for every day that I use Freeform, but you lack some of the tools that you're used to in a CAD system.
Got it. Another question here, is there future scope for bringing in environments from apps like Google Earth and using Freeform to bring the topology to more of an accurate end result?
So I don't know what format Google Earth uses to share and distribute its data. We can import a variety of mesh formats, every STL, PLY, OBJ, and Freeform tends to work more in a micro or smaller scale. So bringing in something that is meters, hundreds of meters, thousands of meters across might not work very well. Since this is more of a manufacturing design tool, you could scale it down. So if something from Google Earth were in a more uniform or more shareable format, you can bring it in. You would be able to view it, and depending on how it is created, not all geometry is the same, and not all systems create models that are designed to be printed or manufactured. You may have your mileage may vary with what you can do with that data. So it's largely dependent on what their use case for their exported data is. And I have personally not played with that in Freeform, so I don't have a great answer, but I can definitely look into that. Since I have this on screen right now, this here is, of course, a solid representation. So this here is traditional CAD type of representation. If I add something like a clay sphere, actually this clay sphere is very large, so I'll scale it down to about 30% and reposition it. So we have two very, very different geometry types. And part of what makes Freeform so nice is I can actually combine these two. So if I take my solid, Boolean combine into, I can choose piece 2 and choose whether I want to combine this as a clay representation or have a mesh as the result. And now that I have that solid as part of my clay design, I am completely free to sculpt. So if I wanted to, say, sharpen that curve a little bit, or come in and smooth things, this all behaves like digital clay right now.
Anybody else with questions you want to drop into the question box? Yeah, this does seem like a great tool for all the kinds of things that would be very difficult in a
That
parametric CAD program, right? All the kinds of use cases. I can remember years ago working with a company in Knoxville that did a lot of injection molding. They gave me the head of a plastic owl, the thing that you put on your
mm-hmm.
roof to scare away critters.
Yep.
And part of what they were asking for was to offset it inward by a millimeter so that they could get the shell that they would mold. And it was devilishly hard to do in parametric CAD, right? Anywhere that the radiuses were too tight, And this seems like it would do a task like that very quick and easy.
Yes, that is one of Freeform's actually primary use cases when it comes to making things manufacturable. So for instance, if I start adding a little bit of surface feature to this, and I'm going to make something that is an obvious undercut. And we will pretend that this is actually even better. We can use one of our sample models from our library. So this is part of our training tutorials. This here is a model we've had for many years. If we wanted to take something like this and make a two-part mold from this model, let's say we wanted to split it this direction. So if I look at it from here, I can make sure that my pull direction is looking straight forward, create a parting line. So this creates a 3D curve on the surface. I'm going to remove the areas that it already found as undercut and smooth this curve, knock it down to about 75 points and fit it on the surface. And from here, in order to make this moldable, we know that those fangs are not moldable. There's some region that will certainly cause some trouble. I can turn on a preview. So if I go to my view, pull direction, show colors, that everything blue is on the backside from this pull direction and everything that is clay colored is on the front. And if I want to remove it, I can choose the front, I can pick a draft angle, and if I select my curve, click apply, right now it's going to cut those away, which I don't want to do, but you'll see that the fangs are going to be removed in a moment. Yeah, that's less desirable. So undo, and I can fill in those areas with the same amount of draft. And what this has basically done is this will create the front side of this as a moldable object that if we split this and created a mold box for, this would be able to be brought into another application or directly used for molding from here. So if I press S and turn back off my colors, you can see that now from this view here, we didn't alter the design too much, but it filled in top of the nose, behind the fangs, everything from the front side of that parting line is now ready to be put into a workflow for a mold design. And that is something that Freeform shines at, preparation for molding. So it's more than just 3D printing, it's manufacturing for many industries.
That is great stuff, and I can't help but get the impression that Dave and I could probably go all day looking at examples here, but I am interested to hear from everybody who's watching this. So I'm going to encourage everybody as we close out right now, reach out to us at TriMech Solutions page if you want to speak up with how that works mechanically in the webinar. I believe there's an email that will go out afterwards. If you think that this could help you in your work, we would like to speak with you.
Absolutely. The recording will be sent out later today. And if you have any questions or you'd like to speak to Dave or Brian, just reply to the email and we'll make sure that they get